Okay, so let's get started with some examples here. For our first example, let's go ahead and look at the integral of the square root of 3x plus 1 with respect to x. And just like when we're doing the other stuff, any of the integrating, of course, we'd like to see an exponent on it. And by definition, this is going to be equal to the entire quantity, 3x plus 1 raised to the 1/2 power with respect to x. And when we look at this, we can clearly see that there is no way to make this look like a basic form. Our basic form has to have x's raised to powers of n. And so we don't have that in here. I've got this other thing that's raised to a power. That means I need to do a u substitution. In a u substitution, I'm going to pick my u, and u is usually the bigger piece, or the piece that's being raised to a power. In this case, that would be 3x plus 1. Based on that choice of u, we go ahead and define our u prime. The derivative of 3x plus 1 is going to be 3. So I come back here, and I look and I see that I do indeed have a u to the 1/2. But what I'm missing is my u prime. And remember, u primes have to be there. Well, if I need a number, I can multiply by that number as long as I multiply on the outside by the reciprocal. That way, in essence, I really haven't changed anything. If I look at that multiplication, it amounts to 1. Remember, I need that u prime on the inside, even though it doesn't come out in the answer. However, anything on the outside of this equation is going to carry down. And so then look at what it is I'm integrating. That's usually why I write it underneath. I'm integrating u to the 1/2 times u prime. And when I integrate that, I get u to the 3/2 over 3/2 all plus c. And then I'm going to flip that bottom one, multiply, and then put back in my u. And I believe that that's going to give me a 2/9 times 3x plus 1 raised to the 3/2 power all plus c. Remember that we can check these results simply by differentiating the answer we just got. Again, don't just start taking a derivative. You want to show me you're taking a derivative. So we're going to take the derivative with respect to x of 2/9 times the quantity 3x plus 1 raised to the 3/2 power all plus c. So that first piece right here is going to involve a chain rule. Let's look and see how that works. We're going to bring down the 2/9, and then we start. The 3/2 is going to come down in front. We will then take that 3x plus 1 and raise it to the 3/2 minus 1, or 1/2 power, times the derivative of what's inside, which is 3. And when I multiply this 3 times the 3/2, those go away. I get 1/3 times 3 just gives me a 1. And so cleaning all that up, you can put your numbers together if you need to see them multiplied together. What I wind up getting is 3x plus 1 to the 1/2, or simply the square root of 3x plus 1. Now, when you get these fractional exponents on a variable, folks, you don't have to do any cleanup on it. You don't, like for example, in our answer here, there's no need to write this as the square root of 3x plus 1 cubed. Not necessarily unless it's a single number. When it comes to 1/2s, I tend to go ahead and put them back in the underneath the square root, but you don't have to. The choice is yours when you're doing this. Okay, let's move on to our next example here. And in our next example, as I said, let's go ahead and look at here. Let me get my pen. Let's go ahead and take the integral of the cube root of 1 minus 2x squared times x dx. Okay, and let's look at this now. Again, the first thing we'd like to do would be to try to make it look like a basic rule. But you cannot take this x here and distribute it. In other words, think about this. If instead of this you had something like the integral of x plus 1 times x dx, you could go ahead and multiply that x in here and then turn it into just a bunch of individual terms where we could apply a basic rule. But the problem with this, and let me go ahead and rewrite this, when I rewrite and see what this looks like, this is actually 1 minus 2x squared to the 1/3 power times x dx. And orders of operation say we'd have to do the exponent before we could distribute. So there's no way to turn this into a basic rule. That means we're going to try for a u substitution. Again, I'm going to choose u to be the bigger piece, or the piece that's being raised to a power, which is a 1 minus 2x squared. And then the derivative for that u is going to be a negative 4x. Now when I look at what I have here, this clearly looks like a u to the 1/3, and I almost have my u prime. Remember, it's possible to get numbers. If I need a negative 4, which remember I have to have the u prime in there, not a problem at all, because I'm just going to multiply on the outside by the negative 1/4. The negative 4 must be on the inside. Remember, it doesn't come out in the answer, but anything in the front will come out in the answer. So the negative 1/4 is going to carry down. When I integrate u to the 3rd times u prime, I'm going to get u to the 1/3 plus 1, which is 4/3, divided by 1/3 plus 1, which is 4/3, all plus c. And then of course I can go ahead, flip that number around on the bottom and put my u back, and I believe this should give me a negative 3/16 times my u, which is 1 minus 2x squared raised to the 4/3 power, all plus c. All right, let's try another one here. Number 3. Let's try the integral of 7 divided by the square root of 4x plus 3. And we've definitely got a problem in this one. There is absolutely no way to turn this into something that looks like a basic rule. In order to do that, I would have to be able to take the square root of that first and then try to make it a single thing and bring it up to the top. It's not going to help me any. So what I'm going to do is a u substitution. Now in a u substitution, I'm going to pick my u to be the bigger piece, or the piece that's being raised to the power, and in this case that makes the u be equal to 4x plus 3. If that's the u I pick, then the u prime that's going to go with that is simply 4. Now, I can see that I'm going to have a u to the 1/2 here on the bottom, which means I can bring that on up to the top. And my u prime is going to need to be a 4. Now let me rewrite this for just a second and show you what I plan to do with this. First off, that 7 is going to have nothing to do with this, so I'm going to bring that 7 on out to the outside. And then I'm going to bring this up to the top as my u to the 1/2. So this square root of 4x plus 3 would come up to the top as a 4x plus 3 to the negative 1/2 dx, which would then amount to my u to the minus 1/2. Why is that? Because remember, we have to do that with any of our variables. If they're on the bottom, we're going to bring them up to the top. But what we still need here is the u prime. And instead of leaving the 7 in and having to worry about how would I turn a 7 into a 4, I'm just going to pull it out and then know what I need. I need a 4, so I will multiply on the outside by the 1/4. Remember, I need the 4 in there in order to do the integration. It will not come out in the answer, but anything on the outside of this does come down in the answer. So the 7/4 comes down, and what we're integrating is u to the minus 1/2 times u prime. And when I integrate that, I get u to the negative 1/2 plus 1, which is a positive 1/2 power, over a positive 1/2, all plus c. And when I flip that bottom one, multiply, and then put back in my u, I believe that what I should get here is a 7/2 times my u, which is 4x plus 3 raised to the 1/2, or put it back in a square root if you prefer, all plus c.